Hello everyone, my name is Meghavi Rathod and today I am presenting traditional methods for machine learning on graphs explained through a real life analogy. Graphs are made of nodes which represent entities and edges which represent relationships. We see them everywhere in social networks, molecules, banking systems and traffic networks. The challenge is how do we apply machine learning when data is not flat like tables but relational and interconnected. To answer this, let's look at a case study. Imagine a teacher trying to predict if two students will become friends. First, the teacher checks mutual friends, popularity, and same clubs. This is feature engineering. Next, the teacher compares groups of students with similar behavior. That is called graph kernels. And finally, the teacher uncovers hidden cliques. For example, football fans clustering together, that is called matrix factorization. Now if you see in this diagram, we can see that all students or people are connected with each other with the social media platforms. Like there are social media platforms which is LinkedIn, Instagram, Facebook and Twitter. Feature engineering means extracting properties directly from the graph structure. It includes degrees, centrality and clustering coefficient. Degree suggests how many connections a node has. Centrality shows how important a node is in the network, while clustering coefficient shows how often a node forms triangles with its neighbor. These handcrafted features are then given as input to ML models like logistic regression or SVM. As we can see in the both images, the first image shows the two clusters which is said that influential node connected to other influential node. If we see the another diagram, we can see that how node A, B, C and D all are connected with each other, and we can see the triangle between node A, node B and node C. Let's come to graph kernels. Graph kernels define similarity between graphs. They capture structural patterns like subtrees, random walks, and shortest path. Subtrees basically shows the hierarchical structures, and the random walks shows the path through the graph. Common kernels include the Weisweiler-Riemann kernel and the random walk kernel. In our analogy, this is like the teacher comparing different groups of students with similar behaviors. As we can see the diagram, two small groups like two small graphs side by side with dotted arrows showing comparison between corresponding nodes. We can see that in the graph 1, node A1, B1 and C1 are being compared to the graph 2, node A2, B2 and C2. Let's come to matrix factorization. Matrix factorization represents graph connections as an adjacency matrix. By decomposing this matrix, we can reveal hidden patterns. The application includes in the matrix factorization is the link prediction and community detection. Link prediction basically predicts if two students will become friends or not. And the community detection shows that it finds the clusters in the graph. It is widely used in recommendation systems like suggesting movies or products or songs. If we see in the diagram, we can see the adjacency matrix is split into U and V matrices, combining to show hidden patterns like student clusters. Although these traditional methods were useful, they had some limitations. First, heavy reliance on manual feature engineering. And the second is they didn't scale well to large graphs. Third point is they fail to capture deep and hierarchical relationships. These challenges led to the development of graph neural networks, which is also known as GNNs. As we can see the applications, we have social networks, recommender systems, bioinformatics, which shows protein interaction and drug discovery. We have knowledge graphs also and citation and networks. To summarize, traditional ML methods for graphs include feature engineering, which is handcrafted graph features, graph in kernels, which measures similarity between the graphs, and matrix factorization, which uncovers hidden structures. We explained these methods through the analogy of a teacher predicting student friendships. Though limited, these methods laid the foundation for modern graph machine learning. Thank you.